Here's an absolute value problem that is a little different than what we've seen before. If we notice, we have the variable z inside the absolute value on one side of the equation and the variable z on the other side of the equation. So you might be thinking, well, how do I solve this problem? Well, we're going to do the same exact thing that we've done with any other problem. First, we look to see, is the absolute value by itself? And it is. It's all alone on the left side of the equal sign. So that means I can go ahead and solve the absolute value. So remember, absolute value is going to give me two different answers. So I'm going to have a branch 1 and a branch 2. My branch 1 is the as is. I'm going to go ahead and put that in quotations because as is means as we see it without the absolute value mark. So this is going to be 2z minus 3 is equal to 4z minus 1. Branch 2, I'm going to say opposite. The opposite of what I see inside the absolute value. So that means I'm going to take the opposite, negative something. And that what's inside that absolute value is 2z minus 3. And that equals 4z minus 1. So notice with branch 2, whatever's inside the absolute value, I set up as taking the opposite. This is one number, 2z minus 3. So I put that inside my parentheses. And I'm going to take the negative of everything inside. Let's go ahead and solve for z in branch 1. So what I'm going to do is I want to get my like terms together. I have a 2z on this side and a 4z on this side. I'm going to subtract 2z, and the reason I chose to subtract 2z is because when I do, I see that this is going to become a positive value on this side. And I like positive numbers. So I always strive for positive numbers. So 2z minus 2z is 0. Bring down the negative 3. 4z minus 2z gives me 2z. Bring down the negative 1. Now I can add 1 to both sides because I want to get like terms together. So negative 3 negative 3 plus 1 gives me negative 2. This becomes a 0 over here. So negative 2 equals 2z. I divide both sides by 2, and that gives me z is equal to negative 1. Okay, so now we're going to look on this side. So in the previous example, I distributed that negative inside. And I said that we could distribute it in, we could divide by negative 1, or we can multiply both sides by negative 1. So for this particular example here on branch 2, I'm not going to distribute that negative 1 in. What I'm going to do instead is I'm going to multiply both sides by negative 1. So remember, this is negative 1 times that quantity. So I'm going to multiply this side by negative 1, which means I'm going to multiply my other side by negative 1. So again, remember, this is one number. 4z minus 1 is one number. I'm going to also multiply that by negative 1. It's balanced. What I do to one side, I do to the other. So this is good. So when I multiply -1 times -1, I simply get 1. And then I have my parentheses 2z minus 3. And then that equals, well, this -1 gets multiplied to everything inside. So that gives me -4z plus 1. So if I now were to distribute this this positive 1 inside, it doesn't change the values of anything inside. So that means this just leaves me with 2z minus 3 is equal to -4z plus 1. I haven't done any math, basically, I've just cleaned it up. So now I want to get like terms together. So in this side, what I'm going to do is I'm going to add 4z to both sides. And I did that because when I add this side together, that will give me a positive value. And like I said before, I prefer working with positive numbers. So 2z and 4z gives me 6z. Bring down my minus 3. That's 0. And this is 1 on this side. Now I'm going to add 3 to both sides. So this gives me 6z equals 4. And now I'm going to divide both sides by 6. So I get z equals, this is going to simplify to 2/3. Okay, so we could very easily stop there and say, okay, well, z equals -1 or z equals 2/3, but does it? With these problems, typically when you have this kind of setup, one of our answers might be wrong. One of those answers could be lying. Sometimes that happens. So remember, when an answer is not correct, in the sense that when we put it back in, it's not going to work, we call that extraneous. So we've got to ask ourselves, is there anything, is one of these answers, could they possibly be extraneous? And the way we figure that out is we go back to the original problem. And the original problem was, let me move my paper up here. My original problem was the absolute value of 2z minus 3 equals 4z minus 1. So I have to test these out. So I'm going to test -1 first. So when I test -1, that means I'm going to have the absolute value of 2 times -1 minus 3 equals 4 times -1 minus 1. All I did was substitute in my first answer choice for wherever there was a z in the original problem. Keyword there is original. Notice I have my absolute value signs back. So now remember, we are simplifying. So when I'm simplifying, I do PEMDAS forward. So those are not parentheses, they act like groupings, are absolute value signs. This is being multiplied. So I have the absolute value of -2 minus 3 is equal to 4 times -1 is -4 minus 1. So that gives me the absolute value of -5 equals -5. What's the absolute value of negative 5? Remember, absolute value is a measure of distance. So absolute value, I'm going to write this over here. Just remember, absolute value equals distance. And distance is always positive. So can 5 equal negative 5? Never. Okay? Negative 5 will never equal 5. So that means z equals negative 1 cannot be an answer. That one is extraneous. That is an extraneous answer. So let's try this one here. We have to try both. Don't assume because one worked that the other doesn't. You have to test them both. So again, I'm going to put it back into the original. I'm going to move this over here. So my original is 2z, so this is going to be 2 times 2/3 minus 3 equals 4 times 2/3, oops, that's a parentheses, minus 1. So this gives me the absolute value of 4/3 minus 3 is equal to 4 times 2 is 8, so this is 8/3 minus 1. Okay, so now we have this fraction thing going on. You could just use your calculator if you wanted to. I don't have mine available right now. So this denominator needs to be 3. So that means in order to get 3 in my denominator, I have 3, and I want to have a 3 in the denominator. Right now it has a 1. I'm going to multiply that by 3 over 3. So now when I multiply 3 times 1 in the denominator, I get 3. 3 times 3 is 9. So this negative 3 is the same as 9/3. Okay? And I'm going to do the same thing with this 1. I need a 3 in the denominator. So that's the same as multiplying this by 3 over 3. Well, negative 1 times 3 over 3 is going to give me negative 3 over 3. So now I can go ahead and do my subtraction. So this is 4 minus 9, which gives me negative 5 over 3. And this is going to be 8 minus 3, which is going to give me 5. And then the denominator is 3. So the absolute value of negative 5/3 is 5/3. And that equals 5/3. That one works. So that means that this is our answer. Z equals 2/3. The other one is extraneous. So you need to go back, you need to plug your answer choices back into the problem to see if it actually is telling the truth, if it works. It's not like you did in elementary school that we just wanted to check to see that you did your math correctly. This is a case of seeing, is the answer telling the truth or is it lying? So you do have to go back and check.